12 o'clock. All right, welcome and thank you for joining us for another episode of the Jane Irrigation Training Series. I'm Richard Restuccia, your host, and today we're going to be talking about Moleaer Advanced Nanobubbler technology. And one of the reasons why I think this is so important is because this is technology that actually cleans water and helps increase yields. So really getting more yields, more product from the same amount of water. We like to call it more crop per drop at Jane, but this type of technology is something that became very interesting to me because, if you've followed our training series, we've delved in a lot of different areas. We've researched different areas, and the more we get into the technology, the more we're learning that there's lots of technological solutions for managing water and managing through the current drought and all the food needs we need in the future. So very excited to be talking about nanobubbler technology today, and taking us on this journey is Warren Russell. He's the co-founder and chief commercial officer at Moleaer. He's been in this industry for over 15 years, and Moleaer started in 2016. I've discovered over the past few days that Warren's a really interesting guy, really bright when it comes to technology and water management. And more importantly, he seems to really care about finding a solution and making things better for his customers and our customers. So it's quite a good combination when you get a guest like this on. So Warren, thank you for joining us today. How are you?
Richard, great. Thanks so much for the introduction, and happy to be here. And hopefully, as you said, I hope that we can share some exciting research that we're doing, as well as sort of applied stuff that I think is really going to be beneficial for sort of the agricultural community or horticultural community. And we're excited to get the word out and help people understand what the potential is, for sure.
So Warren, when I see so many people sign up for these webinars in such a short period of time, I know we've caught an important subject. But what I don't know is, are people signing up because they know what nanobubbler or nanobubble technology is, or because they want to find out? So first thing I want to know from you is, how's the adoption of this technology? Where are we, in the growth phase?
It's I think in terms of sort of adoption curve, I would say we're on a sort of a rapid trajectory. I think it's sort of, as you're pointing out, I think people are very curious about the word nano, and certainly as it applies to nanobubbles, and trying to understand how that might apply in horticulture is certainly a good conversation starter. But I think more importantly, when people start to understand the benefits and the sort of the broad spectrum of uses that you can sort of derive from this kind of technology, and it's sort of covers a few different modalities and parts of that growing or cultivation process. I think that's where we start to see a lot more sort of rapid adoption or understanding about the potential of what we do and how this can really add to the benefit. I mean, you said it perfectly, or Jane came up with it earlier than we did. I wish we had thought about it, but essentially we're focused on sort of a resource enhancement. So helping growers sort of utilize resources more efficiently to improve processes to enhance that output. In the context of horticulture, obviously the bottom line means, growing more crop, more yield. But really from our perspective is how can we do that in a more efficient manner?
And I think this becomes even more important in a year of drought, right? Or 21 years of mega drought here in the West. Because if I'm correct, as the water quality decreases, we have more challenges or more problems with the water. And do you guys help with that?
Yeah, absolutely. I mean, it's a good part where we've got some slides specifically with examples of that, where, people are having to use different kinds of water qualities now that really, wasn't a factor many years ago when drought wasn't a consideration, and now you're dealing with this higher salinity in the soil, and then things like infiltration and improving that and getting that salt mobility in the soil and leaching it out becomes a very important part of that process. We have other customers that are looking to reuse water in a way from sort of wastewater byproducts that are a necessity just because of the cost of water, and looking to one, sort of satisfy an ESG initiative, but also just to offset some of those costs. And now you have really an inferior water quality where they do need to manage things like biofilm inside the line and salinity in the soil. So absolutely, it's a really important sort of stage of the market where it is, and the real need to look at sort of innovative or different ways to approach these problems.
Yeah. Well, we're really excited to see what you have today and learn about what this is and how it works.
Awesome. Thank you. Well, I hope everybody finds it informative. And I think, as you would point out, Richard, I think if we have questions along the way, please sort of raise your hand and then we can hopefully address them.
Yeah, thanks for reminding me. We definitely have the Q&A as well as the chat open, and I'll be checking those as we go along. And as we have been doing lately, for the good questions deemed good by our judges, we have some free Jane giveaway stuff for you.
Awesome. Thank you. So I'll kick it off.
Yeah, you bet.
Awesome. Excellent. So again, thanks everybody for participating today. I'm going to be sort of sharing a little bit of information about what we do, the company, and more importantly, sort of what nanobubbles are, some of the basic fundamentals of the general properties, and how it may impact different things within a sort of cultivation process, specifically the quality of water, the quality of the soil, and obviously as a derivative of that, plant health and productivity from that. So we kind of sort of, I'll walk you through in different parts, but we group sort of the values or sort of benefits into these 5 distinct groups. First and foremost, sort of looking at the role of the nanobubble in reducing water surface tension, obviously as an aid to improve infiltration. Then looking at the sort of ionic dispersion. So it's basically you're adding a lot of charged surface area to that water that helps to keep that ionic dispersion and nutrient dilution sort of more uniformly, or preventing agglomeration of those nutrients. And then the role of oxygen as it sort of results in sort of improving soil microbiology, nutrient conversion or nutrient fixing, as well as then looking at sort of the secondary benefits of how those things can reduce input reductions, things like soil amendments and adjuvants and other things like that. And then, again, if people are out there looking to reuse or use different qualities of water, how we might be able to improve that in some capacity.
Warren, we have a first question coming in, and this person's asking about, and maybe you're going to get to this, but they're asking about, do the nanobubbles stay in the water after the water penetrates the soil, or is this something that leaves ahead of time?
Yeah. So I think I'll best save that one. I'll answer it in sort of the next sort of couple slides when we get into the fundamentals, but absolutely. If we can hold that, and I'll just sort of address it in the next slide. So just a super quick question about sort of Moleaer itself. Again, as you pointed out, we founded in 2016. We sort of do pride and do sort of endeavor to work hard to become domain experts in the applications that we do. We do that through collaborating with different research institutes. We have, I think, currently well over 1,500 installations, of which about 500 of those are irrigation water related. And sort of along the way, we sort of look to sort of continue to evolve and drive our understanding and applied sciences of nanobubbles in agriculture and horticulture applications. So getting to your participant's question. So what are nanobubbles? Essentially, it's a calibration of size of a vessel of gas. We're talking about a gas size, a particle size that's roughly around 2,500 times smaller than a grain of salt. So very, very small, but actually that bubble retains more of the properties of a colloidal particle. I like to think of them as a sort of charged particle versus than a bubble, because a bubble, everybody has a sort of a very common understanding of what a bubble is. And fundamentally how that differs is bubble it forms in water, rises and bursts. A nanobubble, by comparison, will stay stable in bulk solution for weeks or months at a time. So looking at sort of the properties and behaviors and what we sort of deem as sort of most valuable, most important in irrigation is essentially, here you have a bubble that we're producing that's roughly around 100 nanometers in size. It has a high internal pressure, and most importantly, it has a charged surface. So if you can think about size and concentration in relation to colloidal particles, we're generally introducing hundreds of millions of bubbles per milliliter of water. So that's an enormous amount of surface area that you're introducing to water. And those surfaces are electrochemically active and charged. And one of the most important things that we've now become to understand is the role of that nanobubble in aiding in reducing water surface tension. So everybody understands sort of the role of penetrants and surfactants in aiding in penetration of that water. Nanobubbles are a non-chemical natural way to achieve some of those same effects.
Warren, if I had a glass of water that had nanobubbles in it sitting in front of us, would we see it? Would we notice anything different about the water?
No, that's unfortunately, that's the catch-22. You can't see it with a naked eye. You may see some on the web, people shining lasers through it, which is refracting off dissolved colloidal particles that may be in solution. That is sort of a dumbed down way of doing it. That way is not necessarily going to differentiate between other dissolved particles in solution. We use something called a nanosite. It's a laser particle analysis. It's basically looking at your solution. It takes a small sample of the water, is refracting or shining laser through the laser, is refracting off particles, and it's counting and characterizing the size and concentration of those particles. That's by far the most reliable way of actually seeing what's in that water. Does that answer your question, Richard?
Yeah, no, that's great. And very interesting, right? That you can't actually see it, but there is a way to see it. So
there is a way, and there's other surrogate ways of sort of doing it. So we use, when we're looking at surface tension as well, we use a capillary action test, and we look at sort of the rise potential of that water, and then that it's another way of determining essentially the role, at least the influence of the bubble concentration on surface tension reduction as well. So there are different ways that you could approach it, or at least observe the presence in some capacity. And as I was saying earlier in the presentation here, we do, whether we're looking at oxygen transfer efficiency or hydroxyl radical production or oxidation potential, or at least very minimum the size and characterization of nanobubbles, we're collaborating with various academic institutions, both here or in Europe, to look at these things. We do think that independent validation is a very important part of this process, as people are coming to us looking for sort of credible information, not just commercial marketing based stuff. So I like to group the benefits of nanobubbles into these four interconnected but certainly related groups. First and foremost, in many of our applications, we're adding oxygen or elevating the amount of oxygen, dissolved oxygen in that water. What's unique is we're doing that in combination with nanobubbles. So normally you may get just dissolved oxygen. We're doing an oxygen nanobubble, which is a stable secondary form of the gas, plus the dissolved oxygen. And most importantly, from a water quality and perspective, that irrigation water, we're able to reduce the surface tension, which we know has an impact on infiltration. We're also suppressing pathogens and oxidizing algae. And then from a irrigation system hygiene, we are sort of controlling biofilm with the use of these nanobubbles moving through that system and helping to at least prevent some of that scaling, but also that bacterial matrix that may build up inside an irrigation system. So whether you're focused on irrigation uniformity or emitter uniformity or filtration efficiency, things like that, we can have an impact there. And then obviously in the soil, improving soil flocculation, reducing compaction, improving the microbiology of that soil. Obviously, as you change the amount of oxygen there, we're promoting more of the beneficial aerobic organisms. And then plant health. I mean, everything from, the root up, if we can at least promote a healthy soil, healthy root system, you're going to have a healthier, more resilient plant at the end of the day, which may result in, better yields, or better crop protection from diseases or other stressful inputs. So again, sort of grouping into two different categories, we do apply our technology in different parts of the process. So in some capacities, we're treating irrigation reservoirs or ponds or canals. In those cases, we're really focused on improving that water quality prior to it entering the irrigation system. So in many cases, you have greenhouses where you have your reservoirs outside. While it's there, it can accumulate, so some cases, bacteria, in some cases it's algae, all of which is going to sort of impact your treatment process down the line. So whether that means more oxidants, more hydrogen peroxide, more filtration, cleaning, back flushing, that sort of thing, we believe that the earlier that you can introduce treatment in a process, the more benefit that you can have down the line. And then as it relates specifically to plant health, looking at the role of oxygen and promoting sort of the metabolic rates. I mean, we quite frequently, one of the first observations that we see, apart from like the characteristics of the soil, is we see a better vegetative growth in that plant. And that is a direct result of sort of elevating the amount of oxygen that's going to the plant, getting ionic distribution of nutrients more uniformly through the root zone, promoting sort of better root structure, all of which is obviously going to result in sort of a better yield. And one of the other things, a part of that is just a sort of, if you just look at from a foundation level, when you do have that better root system, the better nutrient availability, the better oxygen levels in the soil, we see better sort of drought resistance and better heat tolerance. And so we have examples of that where plants go into these stressful environments and the customers or the clients don't see that same drop off in productivity or yield that they normally do.
That's really great, right? Especially this year in a time of drought where, and what is being forecast is a potentially very hot summer coming up and a lot of plant stress. It's great to see both those things help.
Yeah, absolutely. And I think when you come back to your question about adoption rates, I think when people start to really sort of become educated and understand these different value propositions and understanding that, this, even though this is a non-chemical means of introducing it as something into your irrigation water, it has so many multiple trickle effects. So it's really benefiting so many parts of that process that I don't want to say it's a no-brainer, but it really sort of from whether you're looking at from increasing productivity or risk management to sort of buffer your ability to deal with those unforeseen stresses, then that's where we see this sort of pull through from the customers. So coming back to water surface tension, this is by far the most important and valuable sort of discovery that we've sort of had over the last year and a half, and it's really come as a result from sort of the observations in the field and then coming back and looking at really the fundamentals and modes of action behind it. But again, sort of as I was saying, because of this charged particle that we're introducing in there, we are reducing the intermolecular forces of the water, and which is consequently reducing that surface tension. And I think the best analogy is just, everybody understands what a penetrant does. This is just another means to sort of improve infiltration. And when we're doing that, you see that better sort of emitter uniformity and drainage and infiltration, which I'll show you in the next slide here. There's a project we did in Central California with Maricopa Orchards, use sensors to monitor infiltration and drainage. And I think this is coming back to your reference earlier, Richard. This is a prime example here. Normally this is a particularly challenged orchard, but in this case, rather than using their available allocation, they were having to use their well, and the well obviously had higher salinity levels, and managing that was becoming a lot more problematic. And if you're looking at this particular diagram, you look on the left, you've got the control, and you can see you got two charts here, one of which is the infiltration on the top half. The bottom is the leaching and the salt level that's in that soil. And so what we're looking at is, with the green being the availability of moisture going down to 46 inches, and then the red on the bottom, you can see the salinity level. And so by comparison between the control, which is one area of the orchard that didn't have nanobubble treatment, and the other on the left side, what you see is a distinct drop off in not only the sort of the moisture level, which is attributed to the drainage, but most importantly, you see a pretty substantial reduction in salt levels in that soil as that water now moves through that soil column with a little bit more efficiency. So, if you want to look at that from a perspective of soil amendment reduction, or potentially the amount of water that they may have to apply during winter watering to leach that salt out, we're incredibly excited about these observations.
But that is really exciting about the better removal of salts. And I can see this working really well for golf courses, traditional growers, greenhouses, cannabis industry. Any other places, or one of those may, your biggest growing group right now?
Well, predominantly, we started all in the controlled environment agriculture. So we have a large number of greenhouses, a lot of leafy green production, a lot of vegetable production, as well as cannabis being, again, a pretty fast adopter of this. And the growth of the last 2 years in that particular space has been astronomical for us. And again, I think that it doesn't take a sort of a long period of time to observe what these benefits are. And that's really the good thing. So when you look at the time where we out in the field, especially crops with these longer growing cycles like avocados and cherries and such like, the adoption curve is slightly longer than a cannabis grower that's really sort of getting everything done in 120 days and observing that yield improvement. And then, it's a no-brainer from there.
Yeah. So, and Warren, we have another question coming in here, and this person's asking, do nanobubbles distinguish between good fungus and bad fungus in your soil, or does it just kill all of the fungus?
Yeah, it's not. That's also possibly an erroneous assumption. So, what the nanobubble is doing is actually delivering oxygen to the root zone, which is promoting more of the beneficial bacteria, which as a result of which is rather than oxidizing and activating the fungi, it's promoting the beneficial. So it's more of a case of competitive exclusion than a case of inactivation through oxidation.
Yeah. Okay, great. Thanks for clearing that up for us.
Yeah. The other part that we sort of also obviously looking at as a result of infiltration is this sort of better dispersion of those nutrients. And to give an example, we work with a customer, not a customer, sort of a channel partner and a collaborator called Rainag, and they introduce their fertilizers. They have a line of micronutrient fertilizers that they introduce with nanobubbles. And one of the sort of observations is that when we talk about this dispersion of nutrients, I like to use an analogy of, a sort of a cube of sugar versus a grain of sugar. And that's really what we're trying to do, is reduce the agglomeration of nutrients in that soil. And it's a combination of that surface charge, but better capillary action of the water moving through that soil and dispersing it out. And that sort of making those nutrients more available to those nutrients, so the roots. But again, sort of to make sort of an antidote to help understand that normally when you may be mixing certain nutrients in your fertilizer tanks, and they get what's called a heel, or an agglomeration of those nutrients in the sort of the bottom part of the tank as it sort of precipitates out and settles. And their observation is, they don't get any of that when they have those nanobubbles in there mixed with those nutrients. So I think it's a principle, like I like my sugar analogy. I think it's a simplified way of explaining what's going on, but it really has to do with that surface charge and its ability to keep those nutrients sort of more suspended. And then sort of most importantly, what we continue to track is a reduction in compaction in that soil as well. We see that quite frequently. We use spectrometers to measure that, and a very, very consistent reduction across the board, regardless of the soil type. We see that and track that soil reduction in soil compaction.
So Lauren, we have a question coming in, and it's kind of interesting, right? So this is what do you call this? A nanobubble machine? What it actually produces the
nanobubble generator?
Okay. And does it use a lot of electricity? Does it use a lot of energy? What is the how much is needed to actually create the bubbles?
Yeah, it's an excellent question. So our method basically requires the movement of water through our nanobubble generator, and typically that is brought through with a pump. So depending on the scale of the system, and it will be clearer in a couple of slides where I'll show you some pictures of the actual units that we have. But generally, it's no more energy intensive than pumping liquid. We use that pumping liquid. We use what's called a hydrodynamic diffusion process to basically shear that gas into that flowing liquid, which is then put back into its destination. So no more energy intensive, 200 GPM pump. So call it 5. But I can, again, that may be a little bit more clear in a second when you see these slides.
Yeah. So, okay, what I would consider very reasonable.
Yes, not energy. I mean, high level, not energy intensive at all.
Right. I'm not looking to get a giant bill at the end of the year, and I won't.
No, not at all. Not at all. And I can, in a second, I'll show you specifically like what that kilowatt per hour would be for a typical system. Just for the sake of time, I'll keep going here, Richard, so we can get to some of the case studies here. Biofilm removal, again, looks at that industry collaboration with academic institutions. We did some work with Virginia Tech, written 3 papers on this, looking at the role of nanobubbles in disrupting biofilm not inside irrigation systems, but basically on any type of surface. Could be plastic, could be stainless steel, but also on food and basically any food handling surfaces. And essentially what you have is a scrubbing mechanism. So you have this colloidal particle that's moving across a particular surface. In this case, it could be a pipe. And those colloidal particles are sort of basically attacking or degrading that biological matrix on the surface. In some cases, those bubbles are bursting and creating hydroxyl radicals. And that is helping to remove that biological matrix that's in there. So reduction in biofilm and in improving that irrigation system hygiene is a fantastic sort of secondary benefit of this technology as well. So to answer these questions about, we have flow ranges all the way from 25 gallons per minute all the way up to 5,000 gallons per minute. We do create these 3 distinct sizes to cater for the market. We're in the process of launching a potentially smaller, lower end, more of your sort of passionate hobbyist type customer. But right now, these commercial products are in these particular size ranges. A 25 GPM may be using less than I would say like less than a kilowatt per hour of energy. And then you have this Neo product, which is basically everything all contained within that system: onboard oxygen generation, PLC, optional ozone injection. Then you have this Nexusile, which is generally goes in line with pumping systems. I'll give you an example on the next slide of what that may look like. So in that case, we're not adding any energy. We're just going in line with existing irrigation pumps. And then for the larger installations where we're offering like a turnkey system, we have this large scale modular Titan series, which goes all the way up to 5,000 gallons per minute at the moment.
So do I have to install these in an enclosure in a vault, or can I actually put them outside and let the weather hit them?
Great question. So the Neo, we typically advise weathering enclosure like you see on the left-hand picture here. The Titan series can go sort of be broken up into an irrigation room like you see here, which is a project in Spain that we have 1,000 gallons per minute. And it has its own oxygen generation doing about 7 kilos per hour, or in other words, about 15 pounds per hour. And this Nexus 500 here is in an avocado orchard in Chile, again, in line with their existing irrigation pump, delivering roughly around 100 cubic meters per hour or 500 gallons per minute. So it's a good time to sort of segue over to some of the applied side and talk a little about some of the findings that we see relative to these fundamentals I've just described. This is a project that we did with Maricopa Orchards in Central Valley. It was a couple seasons ago. Really was our first step into looking at infiltration rates. We installed this 50 GPM system on a lateral line. No pump here, just it's using the existing flow of that water. And we used sensors to monitor infiltration rate down to about 46 inches in this case, just focused on this range between 6 and 22. Specifically because that's where we observed a compaction zone. So infiltration was not great. And I'd say within the first month, you started to see not only a reduction in soil compaction, but you start to see this infiltration change. And if you're looking on the right-hand side here, you'll see the moisture levels during that irrigation be much higher than on the untreated side. Avocados, we're doing quite a bit of avocados in Chile and Peru. Again, what we consistently see, salinity is typically a challenge in some of these regions. We're addressing that through all the mechanisms I just described. And one of the things that we're consistently tracking is a better caliber size. So you can see in these photographs that vegetative growth difference on the treated side. But also, more importantly, we're tracking that salinity in the soil. We see a reduction in tip burn quite frequently in the leaves. And what we see is generally a higher ratio or better ratio of that higher caliber or the maximum caliber size of that fruit. So in this case, greater than the 50 and that 14.7% over and above the 10.5.
They're amazing photos, right, where you can see how much healthier the avocado trees are. It's those look fantastic.
Yeah, it sort of comes back to that the cell turgidity and just better moisture availability. It really is quite visual in many cases.
So we've got a couple of questions coming in, Warren, and
yeah.
The first question has to do with cost of the generators. I know that's an unfair question, right? Because all situations are different, but
yeah.
Are we talking about tens of thousands, thousands, hundreds of thousands? What's a good guide that somebody could use?
Yeah, it's a good question, but it's a broad question. It's a broad answer because it does vary. So on the smaller size systems, I haven't checked recently, but I think the smallest size is around $12,000. That may go all the way up to that Titan style system that is the larger flow, everything built in oxygen generation, and we're treating several hundred hectares. That may be $150,000 to $200,000, somewhere in that range. It just really depends. And then sometimes you're going in line and there's more of a prioritization just for nanobubbles and non-oxygen as well. That completely changes the complete scope of what that equipment may be. So it's a pretty broad range between one size to the larger size.
Seems to me that there could be a pretty easy return on investment calculation here. My expected yield is going to be X, and The cost of the generator is wide. Does it pencil out? I mean, is this a good way to evaluate?
Yeah, absolutely. I mean, that's really the better question, and we see ROIs typically less than 18 months. If it's cannabis, it's usually about less than 1 month in some cases. So it's a pretty broad spectrum. Obviously, when you're growing long crops, that it takes a longer time to see prized over time. But yeah, I mean, in blueberries, we're working with one of the largest blueberries growers in the world. They've just now reporting a 25% yield improvement from last year. And, when you do the economics on the cost of that capital investment relative to that additional profit, it's well here in those regards.
Yeah, so and then somebody else is asking, Warren, does your system work with all types of oxygen generators to feed the Nanobubbler generator?
Yeah, we have a particular spec. So yes, I mean, so the most normal type is a pressure swing absorption system. What we care about is basically the air quality and the pressure of that system. So yeah, we try to be oxygen agnostic. So in Europe, we have different oxygen providers. In the US, we have different. So actually, we try to work backwards from where the customer is best supported. We have a preferred provider in the US that we work with, and that's based on the support that we get from them, but that's not necessarily the same for our provider in Chile. So we again work backwards. We always put the customer first in terms of where they're best supported.
Yeah, fascinating and good for your customers. And we just have one last comment here from a gentleman in Chile, and he says he's actually seen the installation on avocados. Greetings, and it works great, and he's a happy customer.
Awesome, we love those. Excellent. Okay, should I jump ahead and then we'll get to some more questions in a minute?
Sure, that'd be great.
Yeah, so this is a project that we were involved with Wageningen, and I'm sure everybody knows of Wageningen as sort of the premier institutes, and we were very, very fortunate to be part of this study. Again, looking at different cohorts, different varieties, different irrigation methods, but we consistently sort of outperformed the control, both in dry matter weights and THC production as well. So very consistent, and we have a pretty significant number of customers that are supported through our channel partners in this domain. And again, I mean, if you're looking at this early example, we have a customer with a system and really getting a payback on their system and with 400 square feet of production. And again, it's that question you're kind of resistant to answer because you don't want to create false expectations. That yield, what is the yield going to increase by? It varies. A lot of it has to do with how much you're pushing the plants and light intensity, CO2 supplementation, all those sort of things can really impact. And what we're looking at is really helping to drive that accelerated growth and help that plant reach that full genetic potential. So it does vary. So I don't want to create false expectations, but we do generally see this 10 to 20% improvement.
Wow, that's a lot.
Yeah, through the sun around here, because we do get a lot of inquiries from organic farmers and looking at that better nitrification of their nutrients. It is a sort of Achilles heel and a sort of a bottleneck for the types of nutrients and getting that sort of consistent ratio. This is actually a large grower down in Guatemala. So probably not your typical location where you would imagine that there's this kind of technology to go. But yeah, they did peppers and tomatoes on their organic line and trying to promote that better conversion of ammonia, and all of which resulted in obviously a better productivity. Blueberries as well. We do quite a bit of work in blueberries. All credit to our partner down in Chile called Capicua. They've led a lot of this development. We have a number of projects between Chile and Peru with some of the largest growers out there. And again, whether it's substrate or soil, we typically see these consistent metrics in terms of reduction in soil compaction, better vegetative growth, and then better caliber of fruits and consequently yield as well.
Now look at that, 75% of the fruits hit the final stage about the same time. That's
Yes.
incredible, right?
Yeah, no, it's super exciting stuff.
Yeah.
In Mexico, we have some sort of organic peppers grown, again in soil. Typical yield improvement, but again, I always attribute that to basically improving the quality of that soil, that root zone, and that reduction in disease specifically. We see a lot of, particularly in Mexico and certainly parts of Chile, you see compromised water quality, source water quality. We had another customer that was irrigating lettuce, and we all know about cross-contamination with source water and irrigating where there may be coliform or E. coli in that source water, and now it's going out to your lettuce fields. And we have applications where we're treating that source water specifically to target those pathogens that may be going there. And the fundamental difference is the system is working continuously 24/7, 365 days a year. So you don't create those opportunities for bacteria to come back in there, as opposed to a chemical treatment that you treat and then basically exhausts, and then now you got to wait for somebody to come back and do it. This is more something that would work synergistically with a type of treatment to really promote the longevity and the sustainability of that process to reduce that pathogen level. We get asked now a lot, obviously, coming back to the front of the conversation about water conservation, water efficiency. Again, this is done by the Capicua group with Cortiva, looking at water reduction, water conservation. Can we sort of utilize in these sort of controlled environments? Can we observe a reduction in water utilization? And again, this case, so I think some people are familiar with some of the other products out there like magnetism, and that may promote some of the same mechanisms that we're talking about today. But this is a comparison study between sort of nanobubbles, magnetism, and then combining the two. I think the results speak for themselves. But yeah, it's from a metric of the potential to reduce water utilization or improve the efficiency of water utilization. That was certainly a good validation there. Cherries as well. I mean, we cross the spectrum. As I said, we work heavily with greenhouses and all the vegetables that go in there. And especially crops, we're doing everything from grapes, citrus, all kinds of nuts, avocados, and cherries is probably one of the more, just based on the improvements that we saw in caliber and size, and being able to essentially move that caliber grade to the super jumbo and super giant in that fashion is considerable value to the grower in terms of the not just the weight improvement, but also just the grade and classification of that fruit. So this is a particular crop that we're hoping to do very well with in this year down in South America.
Warren, we've got a couple. We're going to knock two questions out with one.
Sure.
Out. And the question is, should the generator be applied to the reservoir or somewhere in line? And then if it is in line, or when it is in line, should it be before or after the fertigation tank?
Yeah, good question. No one answer to it. We do all of the above. It just depends. One would be the use rates and the irrigation reservoir size. So depending on how much time we have to treat that. If it's a very large reservoir and there's a high utilization rate, we'd probably elect to go in line. In which case, if we're going in line with that pump, we would go after the sand filters. And then depending on how they're doing their nutrient mix, they may go in before or after. That doesn't really matter. If it's a greenhouse, typically we're going into the day tank. Day tank then feeds your irrigation system, which then consequently go out to your irrigation system. But in some cases, we're doing both. In some cases, we're doing all three. Some cases, we have customers that are really looking to improve the quality of the water. We're treating the reservoir with perhaps like air nanobubbles that go in that reduces the algae, improves everything about their sort of pre-treatment process. Then we supersaturating with nanobubbles and oxygen. That gets fed out. And then the other cases, we're actually treating the return leachate water or the drain water as that's reblended in. So we do all of the above. I think it's specific to the customer needs. And again, if the reservoir needs a lot of help, we may focus there. If we can utilize a pump that gives us a consistent flow, we'll go in line and do it that way.
Great, very helpful answers. Thank you.
Yeah. Did you had one more? You said you're going to ask 2 questions.
Yeah, it was 2 questions in 1 question.
Okay.
You knocked them both.
Got it. Okay. Yeah, just again, another crop, another observation, color distribution. We saw the same thing with grapes, just sort of the maturation of the color grading, more consistent color grading. We attribute that just, again, better nutrient availability, better management of that vegetative growth process leading up to this. And you see just this maturation with more consistency, and you can see on the color grading as well. We do obviously track Brix levels in some cases, and to the extent that we've been sort of involved in that treatment process from the beginning, we do quite frequently see an improvement in Brix content. And what's actually interesting is even in some of the studies that we've done with Nova crop control, we've done 2, one with tomatoes and peppers. What we've seen is even though the size of the fruit is bigger, we don't see a reduction in nutrient levels, and we don't see a reduction in Brix levels as well. So there's no dilution of nutrients as that size of fruit gets larger, which we found to be pretty interesting.
That is interesting.
Yeah. And then lastly, just to wrap it up again, just as we talked about it, he has an installation where we're treating a reservoir. This is feeding a greenhouse. And you can see in the graph, just, looking at turbidity and chlorophyll level, chlorophyll as a sort of a measurement for the amount of algae in there. And these guys went from like their filters being clogged, and having to backflush every day to having it much more maintenance free. And then most importantly, what they were tracking is sort of the ATP, the bacterial level that was in the water that was driving the demand of hydrogen peroxide that they were using to reduce those bacteria once in the greenhouse. And they were able to reduce their hydrogen peroxide levels by almost 50%, or at least promoted that longevity, the shelf life of it by another 50%. So sorry, not shelf life, half-life of it. So the question is, again, it really depends on what we're focused on, where we're trying to add value for a customer. Same type of thing. This is a project in Spain that we're doing with our sort of channel partner there by Via Sabor. And I think the photos speak for themselves. You can see a pretty remarkable transition in the clarity of water. Again, this is just air nanobubbles. We're using the natural coagulation properties of that bubble, plus the ability to sort of collapse and oxidize that algae. And the transformation in water clarity is usually very distinct and quite significant. So if people value that and they're looking at to do it as a sort of an alternative to chemical treatments, or you just want that better consistency, clarity of water because you're tired of cleaning your filters 3 times a day, again, this would be a sort of way to approach that. Another way to approach it. And that's kind of it. By sort of a conclusion here, I think just to sort of wrap it up, and then I think we have some questions as well waiting in the line here. Non-chemical, so it's very complementary. If you are using chemical, if you are using peroxide, hydrogen, could be copper sulfate, or you're using sodium hypochlorite, something like that. This is a complementary tool to really promote the performance of that. A lot of cases we have people that are that they want that level of better sanitation or better microbial reduction. They're scared of ozone because of the oxidation potential, or that you have a beneficial bacterial program that is not complementary, so you don't want to use a heavy oxidant that's going to work against this. This is something that's very complementary. So if you have a good integrated IPM strategy, Oxygen's going to promote that, and it's going to do it in a way that doesn't affect any of those other inputs that you're doing. We have a dual mode of action, right? So we have the combination of the bubbles changing the characteristics of water. We're adding oxygen, so you get the sort of the promotional benefits: oxygen for the plant and the microbiology in the soil, nanobubbles for reducing surface tension, improving the quality of that water. The flexibility of sizes and ranges we've commercialized within these three styles of systems that pretty much covers every kind of configuration you can think of. So adaptability to whether you're growing avocados on the side of a hill, or a greenhouse, or a deep water culture pond, or a small little indoor grow somewhere. We have sort of the option to integrate into pretty much any kind of installation. And support. I mean, we're a US company. We're based in California. We have field technicians that are frequently out there. We have dedicated channel partners in different regions that do a phenomenal job supporting their customers, and us in turn supporting them. So wrapping that all up, and just in terms of that pre-sale support, understanding the process, understanding where we can add value, and then everything else that comes down the line from that, I think we can offer a pretty integrated and satisfactory solution for the market.
So Warren, this has been fascinating, and let's say I want to learn more. What's the best way for me to do that?
We have excellent resources on our website. Certainly, if pressed, right, we also keep a library of academic papers that again support these different components. All of those are available on request. We try to be an open book as much as we can to support what we're pitching here, and whatever part of that is. And again, we have references, we have stuff. Reach out to the websites, and if it's not available on the website, then certainly somebody can be put in contact with one of our business development guys, and they can are all incredibly knowledgeable on what we do. So.
Yeah, well, again, thank you for presenting today. It was really great information. I'm really optimistic about the future of water management when I hear about technology like this, and whatever I can do to help you guys, boy, I want to know. I want to thank all our viewers today.
Appreciate it.
Yeah, you bet. And I want to thank all our viewers today for watching, and so many other great questions. If we didn't get to one, we'll reach out to you on email and get you the answer you need as well. So thanks for watching. Appreciate that. You can find all our trainings at the janesusa.com website /trainings, as well as wherever you listen to your favorite podcasts. So we are going to be back on Friday. We've got a couple of the guys from Water Management Services. They're going to be talking about hacks you can use to start your irrigation season off even better and faster. So Warren, thanks again. Thank you, everybody.
Thank you so much, Richard. Thanks, everybody. Appreciate you listening. Bye.
We'll see you next time. Thank you.